Hi, my name is Mark Plummer, and I'm hoping to pursue a PhD in Spatial Information Engineering at the University of Maine. My research interests are primarily with spatial indexes, particularly the use of alternative projections to improve performance. My background is graduate study in geography, professional experience in computing, and undergraduate study in mathematics and computer science. In 2009, I finished my MS in Geographic and Cartographic Sciences at George Mason University here in Fairfax, Virginia. I focused on geographic information systems, including programming and spatial data structures, as well as the mathematics of map projections. When I finished, I considered pursuing a PhD, but I didn't have a clear view of what my research area would be. I did know that whatever I wanted to study, my mathematics would need to be stronger, so I continued to study in that. Most recently, I finished my BA in mathematics here at George Mason, and my focus has been on analytic and Euclidean geometry, and additionally I've done further reading on space-filling curves and differential geometry and its applications to map projections. I'm also currently working as a geospatial analyst for Courage Services in McLean, Virginia, doing mostly georectification. In 1989, I completed a BS in computer science from Loyola College in Baltimore, and I subsequently worked for 17 years as a programmer and network analyst. My focus was primarily networks and databases. In 2006, I decided to change my career and returned to school to study geography. My research interests are in spatial indexes and map projections. While pursuing my master's degree, I studied Morton codes and their use in spatial indexing. They're most often applied using latitude and longitude. If instead the Earth is projected to a cube, it gives 6 faces on which to generate the Morton codes. And the distortions that you see as the poles are approached aren't seen on the cube. My plan would be to analyze the various different space-filling curves, analyze the various different projection methods, look into the performance of other space-filling curves, develop a reference implementation, and investigate the mathematical properties of the reverse projection of the cube-face curves. Similar methods are being used for astronomical data, for example, the Kobe quadrilateralized spherical cube, but I haven't seen it applied to geographic data. I'm particularly interested in the fact that a minor is required. Further study in mathematics, especially differential geometry, would be interesting to me. And in computer science, a deeper understanding of algorithm analysis and relational database theory would be very useful. I finished my BA this fall, and I'd hope to start work on a PhD in the fall of 2012. I have considered relocating to Maine in the past for work, and it's an area of the country I like a lot. I'd be interested in a research or teaching assistantship, and I hope to be able to join the program. Thank you for your consideration.